Welcome to another session of machine learning, and here we look at logistic regression. So in a previous session we looked at linear regression, and in here we look at logistic regression. So logistic regression is a classification algorithm. So if we want to categorize the data sets into two, we can have logistic regression. So here we have a data set, insurance data, so age, and whether the status, whether that person has bought an insurance or not. So 0 means no insurance, 1 is that he has taken an insurance. So when you look at the age, you can see maybe the younger people, they don't have an insurance, they get gradually older, they have insurance. So probably this is not an if and else program. So you can see sometimes 52, no, 60 years. So so this is the data set. So here I have put import pandas as PD, from matplotlib import pyplot as PLT, and now we read the data set. So if we have the full data set, this is the full data set. So we'll plot the data set. Scatter. So is this name, bought insurance. Marker equals plus color equals blue. So let's see what has happened. Right, we should not have the space there. So plot.scatter df.age, df bought insurance, marker plus color equals blue. So now we have plotted our data set. Next we'll try to train model selection, import, train set, split. And next we have x underscore train underscore test y train y test equals, so we'll have train test split each. Auto insurance train size, so let's keep it 0.8. So let's try to have x test. So this is the test set. So 0.8% of the data is taken to train and 0.2 for the test. So if we increase it to 0.9, we will see less amount of test data. Now here we have six rows of test data. If we reduce the test size and increase the test size, so we previously had it 0.8, now we put it 0.9, and we have x test. Now we can see only 3 records. So now here we will use logistic regression from sklearn linear model import logistic regression. Model equals logistic regression this should be capital. Model equals logistic regression. Model dot fit. So previously we had the split for training and testing, and this is the place where we actually train it using model.fit. Train y train. So this is the place where we train. So just to recap what we have done, we imported the data set and we just had a print to see the data set. So we'll have df.head instead of df, and next we plot the data set. Now you can see we can't have a straight line, so we should have something like sigmoid. So just imagine if a person with the age 70 or 90 gets an insurance, so if you divide it, you can't properly have the linear regression line. So we'll discuss that later. And next we have the training and testing split. So here we have a split. Train size is 0.9 and we have output the test data set as well. And now we have logistic regression from import logistic regression, and here we train. So now we have trained our model. So let's see the predicted y predicted model dot predict x test. So let's see. Predict so you can print the probability as well. Here you can see for the dataset age 27. So this is the probability that this person will get the insurance, and this is the percentage that he will not get the insurance. So this looks still it's not trained, it seems, so we have to change the parameters. That's how these things work. So let's make it 0.8, the test and train split, and and here you can see, so now it seems bit trained. So this is how this logistic regression work. So you have to change these parameters and tune these parameters and see till you get a fairly okay model. Now here you can see the age 7, and there's, if you look at the probability, there's 0.2% of probability that he'll get the that is 20%, 23% chance that he will take the insurance, and 76% he will not take, the person will not take. So it's fairly okay, as the age is very low, that person might not take any insurance, so it might look okay. So there's very high probability here that that person will not take the insurance. So age 29, it's balanced. So previous one is age 60. Age 60, there's very high chance that person will not take this one. And 2, 3, 4, fourth one, age 54. It's also like this. So we have to tune up these parameters, so we will not get the model perfectly fit at the first time. So we have to analyze this data, and based on this you have to change these parameters. So maybe you can change it to 0.7. So you can tune up these things. So let's try to have the model score should be so model score seems very good. So we have this one. So we have the test set. So age 18, 64% that he will take the insurance, and age 45, so it's happening like that. So you can see some of the parameters are still not tuned. Maybe you can adjust various places and see. But this is the overall structure of logistic regression.